point, we're going to start with the different laws of motion formulated by Isaac Newton. So for this week, we will go over with forces and first law of motion. For now, we're going to go over with the concept first. Our objective is for you to be able to, number one, define force. Number two, describe the first law of motion. And third, of course, to identify different examples of activities or phenomena that uses first law of motion. We will be having different scenarios and different examples for you to understand better what first law of motion is all about. What is force? You were right. A force is a push or pull on an object that can cause resting object to move, or it can accelerate moving object. So for example, when you place a book on a table, for example, the book pushes downward on the table and the table pushes upward on the book. That is the reason why the book is staying still on the table. The two forces there are equal and there is no resulting motion of the book. So if the book, for example, is on the table, let's say this is the book and then this is the table, there is actually a downward force and an upward force that are equal to each other. That is the reason why your book is not moving. Your downward force is your gravity. Your upward force is the force coming from the table. Sometimes they call that as normal force. So if on the other hand, you hold the book in the air and then let go like this, the force of gravity will pull the book to the ground. So that's one type of force. So it's usually known as a downward force because it causes objects to go down towards the ground. So it's a downward force. So we have gravity. So when the object is staying still, we don't necessarily see the force, but it is actually present. Okay? So aside from that, aside from gravity, if you slide a book, for example, across the floor or table, the book will actually experience a frictional force. So aside from gravitational force, we also have a frictional force, which acts in the opposite direction of the motion of the book. And this force slows down the motion of the book and eventually bring it to rest. For example, let's say this is your book. Okay, this is your book. And then you push it here, going to the right. So you're actually giving out an applied force. Just you push it using your hand. But on the other side, we don't see it. But there is actually a frictional force or a friction force. Okay, so if certain objects are moving on the ground or on the table, it will eventually slow down and stop because of the presence of friction. Okay, so if a perfectly smooth floor or surface could be created, that's the only time that there will be no friction and the book would slide forever at a constant speed. However, here on Earth, I don't think there's something like that. I'm not sure in NASA if they have a perfectly smooth surface that causes objects to move forever at a constant speed. Okay, but there's no such thing as that, I guess. Okay, but here on Earth, of course, we know that there's friction. The friction is usually higher if the surface is rough, and the friction is lower if the surface is smooth. Now, forces can be combined. So here's the thing that you have to remember in combining forces. So forces in the same direction are added together. If they're in the opposite direction, you have to subtract them. And the overall force acting on the object is known as net force. Now, in the video earlier, it was mentioned that force is a vector quantity, meaning it has a magnitude and direction, and your force is usually represented by an arrow. So the length of an arrow represents the magnitude or the amount of force present in an object. And then your arrowhead, of course, represents direction. So let's say, for example, you have two forces given, okay? And then one of the force here is 5 Newton, and then the other one is 5 Newton. Using this rule, it says forces in the same direction are added together, meaning the net force here, or the average force, is 10 Newton. Because they are on the same direction, you add them and you copy the direction, which is going to the right or positive direction. So that's 10 Newtons. If the force is in the opposite direction, of course, we subtract them. Let's say you have 10 Newtons going to the right, and then you have 3 Newtons going to the left. What you will do, since they are on the opposite direction, you will subtract them. 10 minus 3 is 7. It is positive because it is going to the right. And you can copy the direction of the larger force, which is going to the right. Okay? So net force is the overall force acting on an object. So 7 Newton is the net force. And then 10 Newton is a net force as well. Now, knowing how to calculate it, we can be able to identify if the force is balanced or unbalanced. So when we say balanced force, again, when you combine two forces or forces, it produces a net force of 0, and there is no change in the object's motion. So like what we did earlier, if you have 5 Newton of force going to the right and 5 Newtons of force going to the left, when you solve for them, since they are in the opposite direction, but they have an equal magnitude, when you solve for them, you will subtract them. So 5 Newton minus 5 Newton is equal to 0 Newton, meaning the object is not moving. If an object is at rest, it will stay at rest. There is no change in the object's motion. However, for unbalanced, net force equals the size of the larger force minus the size of the smaller force, and net force does not equal to 0. For example, again, you have 10 Newtons here and 3 Newtons on the opposite direction. You have 7 Newton going to the right. This is an unbalanced force because there is a net force here, and that net force does not equal to 0. So it will cause an object to accelerate, meaning to speed up or to slow down. So your forces, again, are represented by the arrows. So the example that we have here, if they are on the same direction, you will add force, or you will add the arrows, and you will have a longer length. Subtracting forces, of course, you will have a shorter length, and equal and opposite forces, you will have 0. Okay, so let's take a look at the simulator, and we will try to figure out if what I am showing to you is balanced or unbalanced force. Okay, so here. So this is a game of tug of war. I know that you all have tried this. So I'm going to put in here persons with corresponding forces. You have to tell me if the force is balanced or unbalanced. Okay, so let's start. So you have blue team and red team here. Okay, so for the first one, is the force balanced or unbalanced? Okay, if it is unbalanced, which team will win? Which direction will the object in the middle go? Okay, blue or left side? Let's check. Okay, so as you can see, the blue team wins. It is going to the left because they have 150 Newton of force as compared to the right force, which is 100 Newton. When you get the net force, you will subtract them. That is 15 Newtons going to the right. Now that you know about balanced and unbalanced forces, we will go over with the first law of motion, which we call as law of inertia. So Newton's laws of motion, of course, was formulated by Isaac Newton. He was an English physicist, and he was able to do all of this in the 1700s. And these are all considered to be laws because it is proven to be true. So aside from laws of motion, he also formulated law of gravitation and law of conservation of momentum. So if Newton's first law of motion is called the law of inertia, we must first define inertia. So when we say inertia, that is the tendency of an object to keep doing what they are doing, or it's a tendency of an object to resist change. So they just wanted to stay what they are. For example, if an object is resting, it will tend to keep resting. Like the book, if you put the book on the table, it will just keep on, resting there. It will not move because there's inertia. If an object is moving, it will tend to keep moving. And this property is called inertia, a property to resist change. For example, this one, is it magic or physics? Why do the dishes stay on the table when the tablecloth is pulled out? The answer to that is the dishes stay because of their inertia. It's not really magic. Because of their inertia, their tendency to keep doing what they are already doing. So you can try this at home, but you need to use unbreakable dishes. So your dishes there will stay even if you pull out the tablecloth because of their inertia. Okay, they have an inertia. Inertia, in other words, for you to understand better, it has a relationship with mass. So mass and inertia. From our previous lesson, we already know that mass is the amount of matter in an object. And their relationship actually is called directly proportional because the more mass an object has, the more inertia the object has. So they are directly proportional. When one is higher, when mass is higher, inertia is also higher. When mass is lower, inertia is also lower. So meaning bigger, more massive objects are harder to start and stop because they have more mass and therefore they have more inertia. So from the vehicles that we have here, we have a military vehicle and then a yellow car. Which of them has more inertia? Of course, this one will have more inertia because it is more massive as compared to the yellow car. Okay, another example for you to understand the relationship of mass and inertia better. We have here a weighty problem. If you spend most Sunday afternoons at rest on the sofa, watching football and consuming large quantities of food, what effect does this practice have upon your inertia? Explain. So your inertia, of course, because of the relationship with mass, will most definitely increase. Your mass will increase because of this practice. And if your mass increases, then inertia increases. That's why mass is directly proportional to your inertia. So now that you know what inertia is, and we know that inertia is a tendency to keep doing what it is doing, so how can we make changes into it? That's where Newton's first law of motion came into existence. And we call it law of inertia because it basically deals with the law of inertia. So your first law of motion states that an object in motion tends to stay in motion and an object at rest tends to stay at rest unless the object is acted upon by an outside force, which is your unbalanced force. Okay, so this is your unbalanced force. So in order for you to make changes to the object, you need to apply an unbalanced force. For example, the book that is steady on the table because of inertia, in order for that to move, to make changes by movement, then you push it. By pushing it, you're applying an unbalanced force. Another statement pertaining to the law is that it says when an object is moving, it tends to remain moving along a straight path or a straight line path unless acted upon by an outside force. Okay, so if the object, for example, is moving on the left, it will continue to move to the left unless a force is acted upon it. Okay, so first law of motion can be presented through this for you to better understand. So it says, the first statement, an object at rest will remain at rest. So take a look at the example. You have a football. If you put that in the field, it won't move. It will just stay still unless acted upon by an unbalanced force. So in order for the ball to move, you need to kick it. And by kicking it, you're actually applying a force, an unbalanced force to be specific. And then once the ball starts moving, it will continue to move at a constant speed and direction. So how can we stop it from moving? We need to act again, or we need to have an unbalanced force. So it will stop moving unless acted upon by an unbalanced force. So your unbalanced force here is coming from the net, and it will allow your ball to stop moving because unbalanced force is applied into it. Okay, so that is basically your first law of motion. So we feel the effects of Newton's first law every day, like every day we feel it. But usually we don't notice them because other forces interfere, especially here on Earth. There's a lot of invisible forces present, like gravities, frictions, and all of that. But in space, the first law is much more obvious because objects will follow their path until they are acted on by an outside force. So meaning in space, that's why in space, the celestial body are moving at a constant speed, constant motion, constant direction, because there are no other forces acting on them. There are no unbalanced forces acting on them. So you can really see that the object is continuously moving at a constant speed. However, on Earth, the atmosphere itself has air friction, so it will eventually slow down all moving objects. So the ground also has friction. We know that rough surfaces have higher friction, and then smooth surfaces have lower friction. But it gives out unbalanced force, which will allow your objects to move or to stop moving. So an example to that is when you play skateboard. So for example, to stop the skateboard, the skater steps down on the back of the skateboard, so it scrapes on the pavement. This creates friction, which stops the skateboard, but even if the skater will not try to stop it, it would stop sooner or later because of the friction between the wheels and the pavement. So even if you are just standing still on your skateboard that is moving, eventually it will slow down and stop because the ground has friction, and the wheels and the pavement, of course, creates friction. But in a vacuum like space, there is no air friction to slow down object, and the first law is easy to see, meaning you will clearly see that an object in motion will continuously stay in motion unless acted upon by an unbalanced force. More examples. One of the most common places people feel the first law is in a fast-moving vehicle, such as a car or a bus that comes to a stop. So an outside force stops the vehicle, but the passengers are continuously moving. And that passengers who have been moving at a high speed are not stopped and continue to move at the same speed. That's why we need to wear seat belts, because when the car stops, our body is still continuously moving. That's what the law says. An object in motion will stay in motion. So our body will stay in motion and is acted upon by a force which is coming from your seat belt. So that's why it is important for you to wear seat belts. So another example of law of inertia in space, an astronaut in space throws a rock. What will the rock do? Okay, so what is our answer here? Based on the law, the rock will continue to move in a straight line at a constant speed until an outside or unbalanced force acts on it, meaning it will just continue to move constantly in a straight path at a constant speed. Okay, next question. Is a force required? If you were in a weightless environment in space, would it require a force to set an object in motion? So if there's an object, for example, in motion in space, would it require force in order for that object to move? The answer actually is yes. Okay, as what I've mentioned to you previously, mass and weight is different from each other, because mass, even if you are in space or everywhere you will be, your mass would still stay the same, but your weight changes depending on the gravity. So is a force required in space to move object? Yes, because even in outer space, an object has mass, and therefore, as what we've mentioned earlier, if it has mass, it has inertia. And if an object has inertia, then the object is going to resist changes in its motion. And in order for it to move, a force must be applied to set the object in motion, even in space. I hope it is clear now. So to recap, Newton's first law of motion states that things will continue to do what they are doing unless an outside force or an unbalanced force acts on them. There is also a second part to Newton's first law that states that objects will move in a straight line path unless acted upon by an outside force. Okay, so I hope it is clear now. Again, Newton's first law of motion is known as law of inertia.
Thank you so much for watching. I hope you learned something today. See you next time. Bye.